Here we have a planetary gear train shown. We want to find the outer diameter of the external ring gear. So that would be here to here. Given AGMA gears, pitch of 12, pressure angle of 20 degrees, tooth numbers as, so tooth numbers are given, and the thickness of the ring from the base of the tooth to the outer diameter is 0.25 inches. So I'm assuming that's like this little distance. Show our work. So there's a couple of different ways to go about this problem, but I suggest we start at the middle and add up the components. I'm going to start right at the middle, add the components all the way out, and then I'll double it, okay? So the first thing I see is I've got the sun gear, so I'm going to go to the center of the sun gear, or excuse me, the pitch radius of the sun gear. Then I've got, it's in mesh with this next gear, so I'll take the pitch diameter of this next gear. Gets me up to the pitch circle, so I'll call that D of the planetary gear, or which is 2 times the radius of that planetary gear, pitch radius. Then I've got, on top, I have to add the addendum of this planet gear, wouldn't get me to the bottom, so I need the dedendum, the dedendum, which we call little b. And then finally I've got here this thing, that 0.25 inches. And I'm going to multiply all that by 2. So I get 2 times the radius sun gear, 2 times the radius of the planet gear, plus b, plus that 0.25. I've got to multiply the whole thing by 0.25. So if you recall, we have P equals N over D, or D equals N over P, or R equals N over 2P. So that gives me 2 times the sun gear is 15 over 2 times 12 plus 2 times the radius of the planet gear, which is 2 times 8 over 2 times 12 plus B. We need B. That's going to come from our table for our standard gears, and I've got that up here. So B is 1.157 over P. And then 0.25. So I need to add all that up. So I've got 15 divided by 24 plus 16 divided by 24 plus 1.157 divided by 12. 0.25. I think I've got it right this time. 2 times 1.638 or 3.276 inches. That's the diameter that I'm looking for. Okay.